Good day, everyone. We from Group 1 would like to present on finite automata representation of traffic light system. And in this presentation, we will walk you through the states and transition of a traffic light system using the concept of finite automata. Let's dive in and understand how finite automata can model the operation of traffic lights. And the overview on finite automata will be further explained by AINA.
Finite automata, or FA, is a mathematical model of computation used to design both computer programs and sequential logic circuits. It consists of a finite number of states, transition between those states, and actions. There are types of finite automata: deterministic finite automaton, DFA, and non-deterministic finite automaton, NFA. In our traffic light system, we use DFA because each state has exactly one transition for each input. The relevance of finite automata to the traffic light system lies in its ability to model the states, which are green, yellow, and red, and the transitions between these states based on a timer. Its models also ensures predictability, safety, and efficiency in controlling traffic lights. For the next slides, of traffic light system will be presented by SOFIA.
In the traffic light system, we have three main states: green, yellow, and red. For the green state, the light is green and cars are allowed to pass. For the yellow states, the light is yellow, warning cars to prepare to stop. And for the red state, the light is red and cars must stop. These states are fundamental in controlling the flow of traffic and ensuring safety at intersections. Okay, next is transition between states. It will be furtherly explained by Jihan.
Okay, now let's go through the transition between these three steps. For transition 1, it is from green to yellow after 60 seconds. For transition 2, it is from yellow to red after 10 seconds. And finally, for the transition 3, it is from red to green after 60 seconds. Now I will pass it to Nani for further explanation.
Alright, so next is the visual representation. So here's a visual representation of the traffic light system using a directed graph. So we have three nodes labeled green, yellow, and red, an arrow representing the transition between these states. So an arrow from green to yellow with a label 60 seconds. Next is an arrow from yellow to red with a label 10 seconds. Last is an arrow from red to green with a label 60 seconds. So this graph will help visualize the cyclic nature of the traffic light transition. Right, next slide. So next slide is the detail step. So let's go through the detail step of the traffic light cycle. So the traffic light start at the green state. After 60 seconds, the system transition from green to yellow. And then next, after 10 seconds, the system transition from yellow to red. Next is the after 60 seconds, the system transition from red to green. So this cycle continues indefinitely. So this step ensures a systematic and predictable operation of the traffic light system. So for last part is the conclusion part. I will pass to Madhu for present for us for this part.
As the conclusion, we have seen how finite automata can effectively model the states and transition of a traffic light system. So by understanding the states which are green, yellow, and red, and their transition based on the timers, we can design a traffic light system that are predictable, safe, and efficient. Thank you for your attention, and we hope you have a better understanding now of the finite automata representation of traffic light systems.